Hello, in today's step-by-step walkthrough video, I will be using SPSS version 30 to perform, interpret, and write up a one-sample t-test. I recommend downloading today's dataset before we begin. You can also access this resource in the Psychology Resource Library. Here we have our dataset within SPSS. We see that each row represents a single participant, and we just have a single variable. In this example, we're interested in comparing the average time spent on Instagram per day for 15 students within our study to the average that was found for Instagram users in 2020, which is 53 minutes. If we toggle over to the variable view, you can see that we have a single variable and that we are looking at scale data because we're measuring time in minutes. Prior to running our one-sample t-test, we want to conduct some assumptions testing. So we go to Analyze, Descriptive Statistics, and then down to Explore. We then move our variable into our dependent list. We select Plots. And we want to click Normality Plots with Tests, Continue, and OK. To run our main analysis, we go to Analyze, Compare Means and Proportions, One Sample t-test. We then move our variable into test variables. If we go down to test value, this is another term which describes our population mean, or the value that we're comparing our sample to. So in this example, that would be the 53 minutes that was the user Instagram average in 2020. And estimate effect size should be selected as the default setting. We then press paste. Here we have our syntax within our syntax window. We highlight that. We press the run button. And here we have our output. To assess our normality assumption, we look at our tests of normality table and we look over here to the Shapiro-Wilk. We're interested in both the Shapiro-Wilk statistic and the significance value. So here we see that the significance value is 0.954, which is above the 0.05 threshold, and that means that we have met the assumption of normality. Looking now at the output that relates to our main analysis, we can see that we have our mean and standard deviation. Here is our sample size. So we can see that our mean is above the average for users in 2020, but to see whether there is a statistically significant difference between our test value or our population mean and the mean within our sample, we look here at the two-sided p-value. The reason we're looking at the two-sided is because we're going to look at a non-directional hypothesis. And here we see that we have 0.01, which is below 0.05. In other words, we do have a significant difference between the population mean of 53 minutes and the mean for our sample, which is 80.67 minutes per day. The results for our one sample t-test could be written as follows. Students in the statistics class spend 27.67 minutes more per day on Instagram than the average of 53 minutes per day spent by all Instagram users in 2020. These 27.67 additional minutes of Instagram time represent a significant difference from the platform-wide average with a large effect size. If we look for the values to include as part of our write-up, we see that we have the mean difference between the population mean or our test value and the mean that we found from our sample. We also include the 95% confidence interval of the difference, and this tells us that we can be 95% confident that the true population mean difference lies between 7.76 and 47.57. We are then also reporting the mean and standard deviation for our sample. Then we are reporting our t-statistic. Within those brackets there, we have our degrees of freedom, and that is our sample size minus 1. We've also included the two-sided p-value And here under point estimate, our Cohen's d effect size value, and using Cohen's conventions, that is a large effect size. You can access the full suite of resources in the Psychology Resource Library. Follow our YouTube channel for more walkthrough videos like this one.